So now that we have an idea about what a random variable is, we're going to talk about how do we find the moments of a random variable, or basically the mean and the standard deviation of a random variable. And when we talk about the mean of a random variable, we're talking about now that we call this thing, which is this thing called the expected value. And the expected value is the theoretical average of a probability experiment, or if you perform this experiment over and over and over again, what would be the long run average? What would you expect to get? For instance, if you flip a coin a bunch of times, what's the expected number of heads to get, or what's the expected proportion of heads to get? That should be 50%, because you flip, there's only two outcomes. You flip and flip and flip, you should get 50%. And to find the expected value, it's a very simple formula to use. And all it is, we call the expected value E of X. And E of X is equal to the sum of every X times the probability of X. So you're going to take every X, multiply it by its probability X, and you're going to add them all up. And it's literally what we call a weighted average. If you want to find your test grade or your class grade in a class, you would take each percentage for each category, multiply by the amount of points you got in that category, and add them all up, and they'll give you your grade. The same concept applies here. So here's an example. It says Rosemary works for the U.S. Census Bureau in Washington. For a particular Midwestern town, the number of children per family and their respective probabilities is as follows. And you see you have this probability distribution, and here X is going to equal X equals the number of children per family. So X equals the number of children. So it means family can have X equals 0 children, 1 children, 2 children, 3 children, 4 children, 5 children, or 6 children. And notice they give you this distribution of values. And one that's missing is 5. So we're going to be able to find that because we know that all of these values have to be less than 1, greater than 0, which means they're all positive, which they are. And they all have to sum to the number 1. So right now with the probabilities we have 0.07 plus 0.17 plus 0.31 plus 0.27 plus 0.11 plus 0.01. We get all of these together right now equal 94% or 0.94, which means that this value that is missing, the probability, we write like this, the probability that X equals 5, which means that the number of children is equal to 5, is equal to 0.06. And it's 0.06 because now when we write this in here, if you add all those up, it equals 1. The next question asks, what is the expected number of children? So to find the expected number, here's how we calculate the expected number. We're going to say E of X, the expected, also known as mu of X. We call it the mean also. This is the mean, mu of X, is equal to, you take each X, so take the first X, 0, and then multiply by its probability, which is 0.07, plus take the next X, 1, multiply it by its probability, which is 0.17, plus take the next X, 2, multiply by its probability, which is 0.31, plus, I'm not going to write all these out, but what I'm doing is I'm taking each one of these values and multiplying every X. The very last one would be plus point, would be 6 plus 0.01. And when you do all of that, you're going to get that the expected of X, or mu of X, is equal to 2.4, which means the long run average, or if we did this experimental number of times using these probabilities and these X's, we're going to get on average about 2.4 children. So the expected of X equals 2.4 children per family. The next question says, using this table, find the probability of having at most 3 children. So let's talk about this word at most real quick. What does the word at most mean? Well, at most means you can have that many or less. And so when we write this, we're going to write the statement out as the probability that X, again, the number of children, is at most 3 means that it's less than or equal to 3. And we can look at the table now. So we're calculating at most 3, which would be all of the values that are 3 and below. So we're going to add up 0.07 plus 0.17 plus 0.31 plus 0.27. And when we add all those up, we get 0.82, or 82% of the children of the families have at most 3 children. Now, the last question says to find the probability of having at least one child. So when we talk about at least, remember we talked about at least a while ago. At least means that you have the probability at least means x is greater than or equal to 1. And so here in this case, that would be, looking at this table, you see that it's equal to 1, 2, 3, 4, 5, and 6. So it's all of these people right here, or all of these numbers right here. This is at least 1. We can add all those up if we wanted to, but a much quicker way, and the way I want you to get accustomed to using, is the complement here. So at least 1 means 1 minus the probability that x is not equal to, or 1 minus the probability that x is not 0. So x equals 0 here. So this is just 1 minus 0.07, which is 0.93. Let's look at this example. It says companies proven to have violated pollution laws are being fined various amounts with the following probabilities. Find the expected value. So again, it's the expected of x is equal to, take every x, so the first x, 1,000, multiply it by its probability, which is 0.17, plus the next x, which is 10,000, multiplied by its probability, which is 0.47, plus 50,000, multiplied by its probability, which is 0.26, plus 100,000, multiplied by its probability, which is 0.10. So 1,000 times 0.17 is 170, plus 10,000 times 0.47 is 4,700, plus 50,000 times 0.26 is 13,000, plus 100,000 times 0.10 is 10,000. If we add all these values up, we get 27,870. And because our units are in dollars, we're going to call this dollars. But we get the on average, or the expected amount, to be $27,870. The other value we're going to discuss is going to be the variance in the standard deviation. Remember that the standard deviation is the on average deviation away from the mean. Well, random variables have the exact same thing as other variables. So when I look at this, I'm going to want to find the on average deviation away from the mean. In order to do that, we have to find the variance first. And the variance gives the on average squared deviation. Do you remember why we squared these deviations earlier? And anytime you try to find the sum of the deviations to find an average, remember they add to 0. So how do we fix that? We square them. And we call the variance vars x, or var x. And it's equal to, look here in this first part, x minus the expected of x. This right here is a deviation. This is a deviation. You're taking the x and subtracting it from the expected of x, which is also the mean. If you try to add all those up, you're going to get a 0 value. So how do you fix it? You square it. So what you do is you take every x, subtract it from the mean, and then square it, and then you multiply it by its probability. And once you multiply by its probability, you're going to add them all up, and then it'll give you the variance. And the problem with the variance is that it's a squared measure, which gives us no real room for interpretation. So we need to fix that, and we fix it by taking the square root. When you take the square root, you get the standard deviation. And the standard deviation gives the on average deviation from the mean. And we call it SD of x. Or you may see it written as sigma x. Just like you may see variance written as sigma squared x. So let's look at the pollution example again. And it says companies proven to have violated the laws are being fined various amounts with the following probabilities. Find the standard deviation. Well, we already found the expected value, and we know that expected value, the expected of x for this particular problem, the expected of x was equal to $27,870. Well, to find the standard deviation, you have to find the variance first. So we're going to say sigma squared, or vars or variance x is equal to, you take every x value and subtract it from this mean value. So we're going to do 1,000 minus 27,870. And we're going to square that. And then we're going to multiply it by its probability, 0.17, plus 10,000 minus 27,870 times 0.47 plus 50,000 times 50,000 minus 27,870 squared. Square that one, I forgot to. Square multiplied by 0.26 plus 100,000 minus 27,870 squared times 0.10. Now, you can calculate this by hand and get a number here. And whatever that number is, you're going to go ahead and find sigma x, or the standard deviation of x here. And to find the standard deviation of x, you're going to just take the square root of all of this stuff here, whatever all this stuff is. Take the square root of it. And when you take the square root of this, you're going to get this number right here, which is 30,338.64. So this 30,338.64 represents the average deviation away from the expected amount. And remember, our expected amount is 27,870. We're going to deviate on average by about $30,338.64. That's a very large amount that you're deviating by. I'm going to create a video to show you how to calculate all of this value, the variance and the expected value, with using a TI-84 calculator, which is going to make the calculations a lot more simpler.